Okay, so this is video 5.2b because again, it cut my time off for some reason. So if you take a look at this one, as we were doing here, basically the y and the x changed spots. So I went over here and I changed them, and then I plotted the green. And anytime you have an inverse, there's this invisible or this line of symmetry at y equals x. So if you folded this at this dotted red line, the blue and the green would overlap each other. That's all that's saying there. So some properties of logs, these work when b is greater than 0 and b is not equal to 1. So these are some kind of shortcut properties that you should put to memory. And this one, if I put it in exponential, this would just be b to the first power equals b, which would be true. This would be b to the 0 power equals 1, which would be true. This would be b to the x equals b to the x, which would be true. And this last one's a little bit different. I wouldn't even help you with that. I wouldn't even try to derive that one. But if you have b to the log of base b, it is going to be whatever that is, x. And then on number 5, if m equals n, then the log of m equals the log of n, if these are the same numbers right there. Use properties of logs to evaluate. So if we look at this first one here, this would be like a base 10, just so you knew that, is equal to what? So basically, if you change this to exponential, it would be 10 to what equals 10 to the 8th, right? 10 to what equals 10 to the 8th. And this would be, the question mark would be equal to 8. You'd be using number 3 on that screen before. The next one is 6 to the log base 10 of, base 6. We're missing that in this problem, of 12. And this is using number 4, so my answer would just be 12. And the last one here, it would be a base e. So e to the question mark equals e to the 5th, and the question mark would be equal to 5.